Good morning, ladies and gentlemen. It is my pleasure to be with you this morning. The subject of my talk was Get More with Less in AI and the IoT era. However, the complete subject actually is Get More with Less Power Consumption in IoT and the AI era. We know humans are so active. We are so active that Antarctic continent is endangered. We see ice shelf disintegrated and keep integrating. Why is that? I think everyone here, when you were kids, we don't mean to harm the earth. I guess that there was among 1980s, 1990s. At that time, we started to learn everything. But today, with all the mobile phones, tablet, gadgets you have at hand, they all consume power. They generate heat pollution, and that hurt the earth. There are statistics, for example, in cyber mining, they consume a lot of electricity. According to a Bitcoin Energy Consumption Index, 0.13% of worldwide electricity used was for cyber mining. And this number is raising up in a rate of 30% per month. Also, another index is from Digiconomist that all the cyber mining consumed electricity in a year is equal to a number of 1.2% of USA whole year electricity usage. And that number is about 20% of electricity used in Australia every year. We see that the specifications for almost every IoT application in the standard, they claim that coin size cell battery life used for a device in IoT should be more than 10 years. However, I read a report from Design and Reuse that no matter it's a Wi-Fi SoC or Bluetooth SoC, today actually they are much under this standard. Low power is very urgent issue here. What we should do to save Earth and mankind? Let me try to name the moral mission and the vision for SOI Consortium to implement. Let us help the world to consume less electricity when applying electric or electronic devices. Let's devote in building green electric or electronic devices always. I like to recommend FDSOI process. Why FDSOI matches IoT? Because FDSOI achieves planar devices architecture that it is simpler to design, manufacture, and test. It is with 30% fewer masks than FinFET. It comes with lower body biasing. It actively trade-off power and performance by tuning the threshold voltage. The low voltage application of operation becomes possible. For example, 0.4 volt for 8-track logic libraries, 0.62 volt and 0.52 volt for high density and high current bit cells. Ultra low leakage devices approaching 1 picoampere per micrometer. And it's got superior RF and analog characteristics that with these all characteristics, they match perfectly battery-based IoT applications. With that, during the years, we had 2 joint press releases that I like to share with you. And with these two press releases, let's talk about the projects undergoing. In October 2015, we, InVecus, together, we enter a collaboration to win design for GlobalFoundries 22 nanometers FD-SOI and 14 nanometers FinFET process. NDIS supplies IoT tailored CPU cores. InVecus provides design service and sits to GlobalFoundries 22 nanometers and 14 nanometers shuttle run. The data I can share with you today is that the test chip bit was done by InVecus together with IP provided by NDIS. And this test chip is going to be the IoT application platform that can be promoted together by GlobalFoundries, InVecus, and NDIS. And for sure, the design service will be done in future by InVecus. N8 cores was used in this test chip. The NDIS N8 microprocessor cores was used in two subsystems in the test chip. Multi-instance of these subsystems are implemented in the test chip, each with different set of library, for example, ATRAC and 7P50, ultra low power. The tested result I can share today is that it passes 257 megahertz test with ATRAC and 135 megahertz for low LVT. For the measured current data, it will be disclosed by InVecus in weeks. Another press release we did was that 32-bit CPU IP cores implemented on GlobalFoundries 22 FDX technology. Also, the announcement of NDIS joins FD Accelerator program. This program is an ideal platform for IoT, mainstream mobile, RF connectivity, and network applications. We did simulation together with GlobalFoundries. The core used here is NDIS core N25. The process used is GlobalFoundries 22 FDX. With these cell libraries named here, we used the synthesized performance is 2.86 Georgetown MIPS per megahertz, which is high. The synthesized result with 300 megahertz without timing violation. The timing closure shows that the power consumed is 1.6665 microwatt per megahertz. This number is actually 70% of power saving, comparing if we did similar comparison by using leading foundries 28 nanometers ULP. The power efficiency number reaches 1713 Georgetown MIPS per milliwatt, which is very high. There might be a question, what is N25? It is a RISC-V core from NDIS. It is a low power design, and together with GlobalFoundries FD-SOI process, we already see that it is extreme low power. It can reach a high frequency, and it's a world-leading customer instruction extension capable RISC core, a RISC-V core. This is the board diagram and some characteristics of N25, but I don't go into details today. Just like to share with you that in this series, N25 is also come with a derivative NX25, which is 64-bit microprocessor. N25 itself is 32-bit microprocessor, which follows RISC-V iMac ISA, together with a design from ND's 5-stage pipeline CPU. It's a fast, small core that can be used for control tasks in today's application for data center storage, networking, artificial intelligence, and more. In N25 and NX25, we applied some low power design mechanism that I like to share with you here. It's got better performance efficiency. We applied ND's own technology to make it come with zero performance efficiency, which is 20% higher and more. It's got hardware support for misaligned access, and it is good for porting open source. It comes with half precision floating point support that can reduce memory space and memory power consumption. We applied hit under miss cache that can optimize performance with a little additional logic. Also, we applied a single port SRAM to reduce SRAM power, which is significant. So the power management of the NX25 and 25 design, we also applied the ND's own technology power break to digitally adjust power and performance. We applied the ND's technology's quick nap technology that can shutting down logic power. This is the test result with another Foundry's 28 HPC process. The dynamic power is about 10 microwatt per megahertz, which is low. However, as we pointed earlier, that if apply GlobalFoundries FD-SOI 22 process, then it can save up to 70%. Now, taking this opportunity, I also like to share with you the position ND's will be in RISC-V community and the world. ND's plan to provide complete product portfolio, and we will be the most reliable RISC-V core IP business partner, because today in the IP business, there's not many people who do IP business only. ND's is going to make announcement on the RISC-V core that runs Linux in a minute. We always provide low power, so the core we do for RISC-V core will come with extreme low power consumption, high computing efficiency characteristic. We will provide, actually we started to provide world's leading customer instruction extension capable RISC-V core. Very few, I mean, in terms of suppliers. I said in a minute. Taking this opportunity, I like to announce here that ND's will make AX25, A25, again, 64-bit microprocessor and a 32-bit microprocessor available with Linux capability in July. By applying the tool, we call it a Copilot, that available today, and this customer can enable their capability of customer instruction extension. As I said, the suppliers number is very few. Also, we like to lower the entry barrier to use RISC-V core by enabling easy start program for fabless design house and ASIC design service providers. Actually, there's already a couple design service companies in Asia and in US that already signed up the agreements. I'd like to conclude my presentation with two slides. One is that And this will keep our aggressiveness in RISC-V community and the industry. We will be aggressive player in RISC-V course and it's an ecosystem. I know everybody of us, we all love Earth, and let's commit to deliver more with less, much less power budget for all the device we are going to design, to manufacture. Thank you. Thank you very much.